Okay, good morning, everybody, and welcome to the webinar of today. It's one of a group of webinars that this project is preparing. Just a few days ago, every one of us has participated to the quite interesting webinar organized by Transport Authority on the sorry for that, on the smart noise metering port system that they are developing in Patras. And today I will share my screen, of course. Here it is. Just a moment. Okay, that's good. No, that's the screen. Here it is. You can see the screen of the webinar agenda.
Yes.
Okay.
Yes, we can.
So the title of this webinar, which is organized by us, CIRIAF, together with the Mayport Authority, and we want to talk about the work made during the project, but not only during this project, made on the port noise environmental impact assessment. Of course, it's the main part of this webinar will deal about the work made by CIRIAF and by Mayport Authority on the project Anchor Life. But first of all, of course, after the presentations of our part or departments of the project, there will be a sort of introduction made by Professor Borelli of the University of Genoa. University of Genoa, with Professor Borelli and Professor Schenone, is directly involved in the project, even if it is not a partner, but it has been one of the founder of the owner of the ideas for the project, with Simona, which was a former student and doctoral research of University of Genoa, Simona of Ingegnia. And Professor Borelli, as you can see, it will give us an introduction on the Report project, which is a project that was that dealt with arbor noise, and the title of his presentation is exactly a multidisciplinary approach for arbor noise pollution reduction, the Report project. So, since the dissemination and the conjunction of the various projects that deal with the same argument is quite important for the LIFE program, the connection with the Report project is really one of the moments of dissemination, both of Anchor and Report, that are needed for the good success of the LIFE fund. After Davide, there will be Jaime from Mayport Authority, which will give a light on how it is possible to translate the planning data of the Mayport Authority. Mayport Authority is involved in an expansion of its port, and he will give us tips on how all the data that derive from the planning are useful to use in the port noise analysis. So a sort of filtering, operational filtering that they did to translate all the data of the planning to useful for noise. And finally, before the discussion, Dr. Samuele Schiavoni, on the other and will tell us to all the audience what was the procedure and the results right now on assessing the noise impact in the port expansion design. So he will tell us how we used Jaime data to prepare the noise impact of the port expansion. After this relation, there will be space for discussion, and then the webinar will end. I take the occasion as I was the first speaker to tell what CIRIAF does in the whole project, not only in the port noise environmental impact assessment. CIRIAF is also involved in the design of the smart noise port metering system, and worked side by side with Livorno to understand their developing of the figure of merits in Livorno Port Authority, and in the spreading of this figure of merits in the other ports. Of course, CIRIAF is also involved in the other tasks of the project, dissemination and definition of indicators and whatever. Also with an external assistance that CIRIAF used last year. I don't want to go on more than this. I leave the word to another partner. I don't know, Giuseppe Costa or Simona, who wants to talk first. Please feel free to go on.
I will make a first presentation of the overall project, and then the other partners will expose what they are doing about that. I'm sharing my presentation. Okay. Okay. This is a brief presentation of the overall objectives of the project and what we are doing, especially in this this program of webinars. We are going on to do in this year, in this months, and in the next year until the end of the project. Let's talk about the overall objectives of Anchor Life. Anchor Life aims at communicating and disseminating the research outcomes on noise pollution due to urban ports that affects territories and communities in the neighborhood. Anchor Life wants to raise awareness of decision makers, port authorities, public administration, private sector operators, as well as professionals, researchers, and also citizens living in the port cities. And Anchor Life aims at engaging stakeholders towards mobilization and replication in all European countries. The main outcomes of the project are developing an incentive scheme for private sector working in the ports of Livorno and Portoferraio. They are called figures of merit. The second outcomes is designing and installing a smart port noise monitoring system in the port of Patras, Greece. And the last outcomes is to develop an updated port noise impact assessment guidelines to define a common approach in port noise monitoring and assessment. And we are considering also the algorithms defined by the new Annex 3 third of the European Directive on Noise Pollution. the so-called Knossos algorithm. And this activity is carried out in the Melilla port in Spain. Let's talk about the replication objectives. The replication objectives are engaging stakeholders, we have already said, to perform consistent environmental assessment and action planning, building, disseminating, and replicating governance tools for port noise management, and we are going to transfer knowledge to an anchor followers platform, a group of port management related stakeholders. And we are evaluating the effectiveness of this dissemination process through the set of communication and dissemination KPIs. The objectives of this set of webinar is to disseminate our outcomes to a wide community of stakeholders at the EU level. The area of the dissemination are, of course, policy making, technical, regulatory, and also smart technology. The audience of the webinars are port authorities, municipalities, and associates. This is the audience of the anchor follower platform. We have port authorities, municipalities, and associations. Private sector operators. The list of webinars we are going to. This is the second webinars of this list of this month, and please follow us to our Anchor Life website and all our social networks on Facebook, Instagram, Twitter, YouTube, and LinkedIn. Thank you very much.
Okay, good. I don't know who wants to go on with the presentation of the partner. I don't know, Costa perhaps, or Simone. Just a few words.
Good morning, everyone.
Hi, Simona.
Hi, I'm Simona from Ingenia. Ingenia is a spin-off of the University of Genova, and we are involved, of course, in the Anchor Life project as a technical partner, and we are in charge of some actions in the project, and also to be as a support the other beneficiary partners, as for example the action that involved the port authority of Livorno, the figures of May, and also the municipality of Patras for the installation, the design of the smart port noise monitoring system in Patras port, as I said. And we are also in charge for some preparatory actions. For example, the development of the KPIs of the project, and also for some other activities related to the monitoring and the evaluation of the performance indicators for the quality plan, and also for replication plan and the results transfer. So we are in a sort of two levels of involving in the project. We are in Ingenia quite formed in the University of Genova, and we have the bigger research activities for the noise in ports and also in the environmental. So we are partners also for some technical issues in the project, and also we are in charge for the final events that will be held in the next year. So we are a little late because of the COVID situation, and as you already know, we got an amendment to delay the final event of the project. So we are going through all this situation as well as we can. So like that, on my side is everything for this brief presentation of Ingenia and its role in the project, in the For Life project. Thank you.
Thanks, Simona. Thanks. Perhaps Costa wants to say something, or Alessio for Livorno. Costa, are you there? Or Alessio, are you there?
Yes, I'm here.
Or if you want to say something about the...
Yes, I have a little presentation.
Please go on. Thanks.
Okay, I'm going to share my screen. Give me 1 second. Okay. 1 second. I'm trying to... Consenti Zoom. One second, because I have a new PC, so I have to authorize Zoom for share my screen.
I think we have missed Alessio. No. Okay, he's reconnecting now.
Okay, I'm back. I'm sorry.
Yeah.
I'm trying to share my screen again. Okay.
That's it. We can see it now.
Okay, nice. So let's try. Okay. So in the first slide, we can identify the negative effect that have occurred in terms of port traffic in a history period of crisis. Unfortunately, due to the difficulties originated from the pandemic, port traffic in the port of Livorno has suffered a large decreases. Therefore, we could not ask the port operators to include the figure of merits if the traffic was really low. As you know, the figure of merits are incentives that are implemented under normal traffic conditions. If they are reduced as happened last year due to a pandemic, the figure of merits lose value. To be able to implement them, it is necessary to wait for the condition to normalize. In the first 3 quarters of 2020, the port system of Livorno lost and 17.8% of traffic compared to 2019 levels. On the other hand, let's go now see what the figures of merits are and how the acoustic impact can be reduced by identifying the types of activity that operator can carry out in a more sustainable way. On the left side of the table, there are the figures of merits. Scrolling to the right, it is possible to identify how they are measured, the type of measured, and how they can be detected, and which categories of traffic they can refer to. An example, as we can understand from the table, maybe encourage port sustainability with the use of electric handling vehicles inside the terminal to try to reduce noise as well as an environment pollution, thanks to less noise engine. Another example may be to encourage, for example, the use of electric ships that arrive in the port of Livorno. Now we can continue by identifying the incentives that can be given to the operator to carry out any type of operation. All of these are identified in the texture table. And here we can see an acoustic mapping that we have made with another European project, namely Monacoman. Now, you may wonder why not doing it with Anchor Life. We did not make an acoustic measurement on Anchor because we simply already had the data available for analysis mentioned above. So it is also valid for Anchor Life. It turns out to be mapping of all areas of the port of Livorno. Now, figures of merit, how we are managing them. We have a recent acoustic data available, and thanks to aforementioned before data, we are able to carry out a simulation study of the figures of merit by simulation what happens in the port if the port operation were able to implement the noise pollution reduction that we find in the slide. This study is done to comply with the lack of traffic that did not lead to the creation of figures of merits. We tend to simulate the noise pollution of electric handling vehicles, electric ships, and the reduction in the speed of operation. And this is a little presentation of our activity of Anchor Life. And if you have any question, you can mail me on this email or Riccardo Di Meglio. So thank you to everybody for your attention.
Thank you, Alessio, for this quick but comprehensive review of the activities of Livorno Port Authority. You can stop sharing the...
Yes, I'm trying.
Okay.
Okay. It's a new PC. I'm sorry for before, but...
No problem.
Thank you.
Time for Costa, if he can hear us. Are you there, Costa? Yeah, I can see you.
Yes. Good morning to all.
Morning.
A moment to share my brief presentation.
In the meantime, I say good morning also to Davide, which is connected now.
Hello, good morning.
Nice to hear you.
Okay. Yeah.
Morning. Whenever you are ready, Costa, please go on. Eh? Here we can see. Good.
It's okay?
Yeah, it is.
Okay. Okay, I will present briefly as last Monday, the monitoring system of the smart monitoring system applied to the port of Patras. We try to recent math to capture more accurately the acoustic environment in the area of port of Patras. And from last September, we proceed to 20-hour daily continuous measurements in 4 parts of this area, the result of which are posted in every 2 days on an environmental Facebook page of the municipality of Patras. We can see from above the 5 finally was 4 measurement areas in the port of Patras. Point 1 and point 2. Point 1 is the control tower of the new port of Patras. Practically, we already implemented more than 2 months today of measurements recorded through this software in this type. This is a measurement in the gate 2, the gate of the new port of Patras. This is a photo from the control tower. In this photo, we can see the installation of the sound measurement station in the gate 1. And this indicative measurement as recorded in control tower. And the view from the area of monitoring system. We will continue for until 1 month carrying out daily measurements, linking these results to the potential impact assessment, and possibly finding new measuring points as from the measurement till now we didn't find heavy levels of sound, and formulated at the end proposals for dealing with these defects. This is my brief presentation. Thank you very much, Giorgio, for the organization of this webinar. If someone wants to formulate a question, I am at your disposal. Thank you very much.
Thanks, Costa. Any questions? Not only to Costa, but also to any other partner if there are any. Okay. Thanks again. You can stop sharing the slides, Costa. So I think it's time now for Davide. I say again good morning, and do you have something to share, David? You can do it now. I already presented you, and thank you again. The title of your presentation was already shown before, so please, whenever you want, you can go on. I see your microphone switched off. Okay.
Okay. So I can share my screen,
please.
Okay. So I think it should see now.
Yes, now we can see it.
Okay, so I will start the presentation. Okay.
Perfect. Please go on.
So my name is Davide Borelli, and I'm a researcher from the University of Genoa, and I will talk you about a sort of a cluster of projects which were funded within the Interreg Maritime program, which is a cross-border cooperation program between Italy and France. So the problem, as you all know, is that ports in the Mediterranean area, in specific area, often surrounded by urban areas, by cities which are densely populated. And of course, there is a huge environmental impact of the ports on the surroundings and on the cities. And one thing that we all know is that ships are the main source of noise and of pollution in general in ports, because they are really huge if compared to the surroundings. Here I have a short video which shows that sometimes people say a ship is as big as a building, but actually a ship is much bigger than a building. It's almost an entire district, and this has to be really understood to really feel the size of the problem that we are facing. So this is a ship which arrived in Genoa 3 years ago. It was the biggest one of the MSC, and as you can see, it's really huge if compared with the maritime station, which is near it, with all the city, all the buildings. And when it's at K, its engines are always on to provide energy for the crew, for example, and for the passengers. And the funnels are always smoking and making noise. So this is really a huge problem. This is the maritime station in Genoa. This is the ship, and usually there are many of them there. So this is a problem which is really felt in these years. Of course, it's since not so many years that we are talking about port noise, but it's there is also a lack of knowledge and a lack of regulations about that, because ports are usually treated as industrial sources. So there was really a need to study more this topic, and the maritime program between Italy and France, the program which was from 2014 up to 2020, it has just finished, had a specific focus, a specific financing scheme on to finance some projects about port noise pollution. So this is a brief introduction to the Interreg position in the European Union funding structure. It's one of the key elements of the European Union supporting cooperation across borders to Project Founded. This is the Interreg in general. I think that maybe you already know this kind of programs, sorry. And of course, aims to tackle common challenges and find shared solutions in several different fields. It's funded by the European Regional Development Fund, and there are different kinds of programs which can be cross-border, transnational, or interregional. The one that we are talking about is a cross-border cooperation program, and I will go faster in this. And this is the area of cooperation. The slide is in Italian because the Maritime Italy and France program just allows two languages, which are Italian and French. Nothing can be written in English, so I had to choose between one of the two for this slide because this is taken from the website, and I choose Italian for obvious reasons. But anyway, as you can see, there is a small part of France, which is the PACA region, Alps, Maritime Alps, and Var districts. Then there is the Corse, the entire island. And for Italy, there is Liguria and Sardinia, and the coast of Tuscany. So these cities, Grosseto, Lucca, Livorno, Massa Carrara, and Pisa. The area of cooperation is very small, but as you can imagine, there are many important ports within this area, and so the problem is really felt in this area. So I will skip some things because I don't think we have so much time. And within this program, in Axis 3, Lot 2, there was a specific objective, which was the improvement of the sustainability of commercial ports and logistic platforms to reduce noise pollution. And the thematic objective and investment priorities were promoting sustainable transport and removing bottlenecks in key network infrastructures by developing and improving environmental friendly, including low noise and low carbon transport systems, including inland waterways and maritime transports, ports, multimodal links, and airport infrastructure in order to promote sustainable regional and local mobility. And of course, we focused on noise pollution. We also participated in another project which was dealing with liquefied natural gas use in ports, but we mainly worked on noise projects. 5 of them were financed and formed this sort of cluster in which the project in which we cooperated the most was Report. Report is the project that we lead as the University of Jena, which was connected with the other 4 projects, namely Rumble, Monacoman, Lisport, and Decibel. And I think that many of you already know this, at least people from Livorno, because they also are involved in many of them. They lead the Monacoman Project, for example, and they are participating also in Rumble, in the Decibel, and maybe also in List. Anyway, these projects had their own objectives, and they all worked together with the Report, which acted like a leading project. Report was a project just about scientific issues. The partners were all scientific institutions, and its aim was basically to give some instructions, so to say what to do to the partners of the other projects, and to gain the results and analyze them. Talking about each one briefly, we have Rumble, which is led because it's not finished yet, by the Liguria region, and the acronym means in English noise reduction in large port cities in the cross-border maritime program. The general objective of Rumble was to improve the sustainability of commercial ports, contributing to reduce the reduction of noise pollution by carrying out studies, small infrastructure and investments for noise mitigation and for the evaluation of their effectiveness, which can be replicated in all the port realities of the population areas. There are partners which are the Port of Cagliari, the OTC of Corks, the Office of Transport and of the Corks region, which involved the port of Il-Rus and the port of Bastia and Ajaccio. We had the port of Portoferraio in Isola d'Elba for the Tuscany region. And we have also Nice, the metropolitan area of Nice. And of course, we have the port of Genoa in the project. Different investments were made. For example, sound absorbing asphalt was used in Cagliari and in Portoferraio and in Il-Rus. In Bastia, they bought electrical cars for the ports, which of course make less noise, but I don't really think that was the main issue regarding noise in the port of Bastia. I mean, I don't think that the solution is to buy electric cars to move within the port. But anyway, that was one of the investments. In the port of Genoa, the analysis was on a huge infrastructure, an artificial dune, which was financed outside of the project. And so in Genoa, we made the monitoring of all the construction phases. So we monitored the noise of the port before the building of this artificial dune. We monitored the noise during the construction phase and the effect after this construction phase. Although it's not yet complete because, for example, trees are supposed to be on this artificial dune and they are not there yet. And of course, trees will lead to some effect, to some sound absorption if we talk about noise. And finally, Nice already had its own monitoring system. So Nice simply bought some more sound level meters to be installed within the port, and they shared their knowledge because, for example, the port of Genoa and the port of Livorno didn't have yet at the beginning of the project their monitoring station. I want to underline that all these projects were really connected because they were almost made by the same partners. And within the program, it was not possible to fund just one huge project about port noise, but several ones had to be funded because the limit was 2 million euros. So they funded many instead of just one. Then there is the Monacoman Project, which was dealing mainly with the monitoring system, so the installation of monitoring systems within ports. and the commercial ports involved were Genoa, Livorno, Cagliari, and Bastia. And actually, in Monacoman, then it was the port of La Spezia which was involved instead of Genoa. But anyway, the topic here was to share a common approach on monitoring system to see where it was the best, which were the best places to put monitoring stations, and to learn what had to be recorded by this monitoring station, and how the data should be accessible in order to be evaluated, to be studied, and also to be shared with the community, which of course is one of the end users of these monitoring campaigns. And people usually want to know what's happening, want to have the possibility to access this data. So also a database infrastructure was developed within the project and will be accessible before the end of the project for the people which is interested in knowing the monitoring results of their campaigns. This part was led by the University of Cagliari, and it was a project about the intelligent transport system for traffic management. And they monitored the noise levels within the ports and in the main roads, and they modeled the networks between the port, the road networks between the port and the surroundings and the city, in order to obtain virtual models which are capable of simulating new network scenarios. They did not use common softwares which are normally used in these kind of problems, which are ray tracing based softwares like Soundplan or MitraSig, but they made simulation using their own developed code, which used artificial neural networks, which is an approach which is really good for traffic noise, because it can easily model changes on the traffic, and it can learn by itself what changes and what will be the effect of these changes in traffic, and what will these changes represent on the noise pollution of the surroundings. So they used an approach which is not common in these kind of problems, but it was validated by measurements and also by traditional simulations made with ray tracing softwares. Then there is Decibel, which is a sort of equivalent of the Rumble project, but this deals with small ports. So Rumble was about big, huge ports like Genoa, Livorno, Cagliari, and Bastia involved, and Decibel involved smaller ports like Bastia, Il Rus, Olbia, Portoferraio, and Isola del Giglio. The problems in small ports are definitely different from the ones of big ports. For example, you don't have goods, you don't have containers. They are just almost ports for tourism, and when goods reach these ports are on RoPax vessels, and these goods are on trucks, so it's not really the same. They don't usually have cranes that make noise, etc. So the problems are really, really different, and also the issues with these ports are different, because, for example, we found after first attempt that in Isola del Giglio it's not possible to use sound-absorbing asphalt, because there is a local law which says that the pavement surrounding the port has to be made by a particular stone of a particular cave of Isola del Giglio, so you cannot do anything about that. And so they have really, really different issues, and also the solutions you can use have to be precisely designed for this kind of ports. So this was again a really interesting project, and we helped in doing the measurements, in the decision-making process of the interventions that it can be made in the project. And finally, we are talking about Report, which is the one that the University of Genoa lead, and it wanted to act as a trade union between all the previously described projects. The partnership was because the project recently ended, but we submitted the proposal for the 5th call of the program in order to fund Report 2 project, in order to try to implement the solutions that we found within Report. So the partnership is made by the University of Genoa, ARPA Toscana, the Regional Environmental Protection Agency of Tuscany, the University of Pisa, the Centre Scientifique et Technique du Bâtiment, which is a French institution, a French research institution, and the University of Force, Pasquale Paoli, and the University of Cagliari. Within the project, one of the main goals was to develop something which isn't present actually nowadays, which is a sort of numerical model in order to properly simulate the noise pollution coming from ports. So we can say it was developed in form of a module of a commercial software that already exists, which is Mitra SIG, which is developed by the Centre Scientifique et Technique du Bâtiment. So we developed this code, which allows to simulate the particular kinds of sources which act within a port. It allows to simulate the effect of the water, which is almost perfectly reflective, and it's a kind of reflective surface which is presented only in ports. You don't find such a reflecting surface anywhere else. And they also developed a module in order to parametrically build ships and it's very easy now to build ships within Mitra SIG with this module, which is very effective, and it allows you to choose between several kinds of ship to place the funnel on that and all the various sources. So I think that it's really something new, which other softwares doesn't have, and it was completely developed within the Report project. So we made this new simulation tool. We analyzed all the data coming from the other projects regarding the monitoring, the management, and the corrective actions. And also the University, of course, as a partner, they were not from an engineering faculty, they were from the economics faculty. and they studied the social cost of noise and the chance that people would pay in order to have less noise. So a sort of monetization of the noise pollution in order to understand its real value. So the results of all of this study are some sort of instruments, some guidelines that we hopefully think that can be replicated in every port reality, and that will allow to deal with this important issue of noise in ports and to assess the impact of this noise. I don't know how much time I have, but I would like just to show you some of the things that I talked about. So this is the port of Genoa. This is where the dune was supposed to be built. This is a section. These are this is the construction phase. We made measurements in 3 different lines, because and so 6 different points, and at the same time, because the port is really big, so you cannot take a measurement just in one place and presume that your results are the same for every other place. Also because the orography of Genoa, the topography, as you should know, you may know, Genoa has the sea, and the mountains are in front of the sea. So the noise, the receivers are in really different places, also in height and in distance. So the effects are completely different. Some receivers hear the ship, the low frequency noise of the engines. Some others don't, but they hear the container transport, etc. So this is I want just to show you a video of what they can hear during the night, just briefly. So as you can see, I think you could several noises, a constant low frequency noise, which were the engines, and then you can hear signals, sirens, containers, maneuvering, several noises, and this was at 2 in the morning, so during the night, and you can imagine this in summer when you open your windows and you hear all of this noise. The monitoring was made. One thing that we found is that it's very important to have the chance to record the noise, because not all, we wanted to focus on the noise which was of the port, but we couldn't understand that without hearing what we recorded, because otherwise we could have thought that all these peaks were containers or something like that. But actually, the most of the time, the noise is coming from vehicles, from motorcycles, from trains, from seals, birds, things like that, from dogs. So hearing the time history, we could focus on the noise which is really coming from the port, and not all the environmental noise of the surroundings. And this is one thing that is really important, because otherwise, with the common methods, you have an overall estimation of the environmental noise, but you don't really understand what the noise coming from the port really is. And the last thing that we used was an acoustic camera. This is one of the largest cameras you can find. It has 3 meters and 40 centimeters diameter. So we can, it's specifically thought for outside applications, so industrial noise, environmental noise, and it can also record low frequency. You can record from 66 hertz up to 13,000. So it's quite a broad range, and it's useful in order to assess the noise coming from the ships, which is usually a low noise. And again, this is very useful for the definition of the different sources which act within the port. I will show you again briefly some seconds of the video in order to let you understand how many sources are acting at the same time. And also the problem is that sometimes you can see sources which are not actually there, because, for example, this is a reflection of the air vent which is here on the side of the ship, but the fact that we have water here makes this source doubling, we can say. So there are really some specific effects that we can find only in ports. Okay, so you can imagine how difficult it is to evaluate all of these with just a sound level meter. And if you want to make simulations, then it's really difficult to understand which were the sources emitting in at which time, and their spectrums. And this can be easily done with an acoustic camera, which allows you to, in the post-processing phase, to choose just one source. For example, here, the main source in the last second is this one, not the ship vent. And you can then select them in the post-process and see the spectrum that this one was emitting at a certain time. So you can properly analyze all the sources in time, in space, and in frequency. It's unbelievable the things that you are able to do using an equipment like that. So we think that this can be the future in order to characterize sound sources in general, but within a port area when there are so many sources which are acting at the same time. And then we can use all of this information to make simulations which will be accurate. Now this is the port of Pra, for example. These are horizontal maps at 2 different aids, which is particularly important for Genoa, because this is the orography that I told you about. So when a ship is here, you have receivers at the sea level, but you have also receiver on the hills. So, and the noise that they receive is completely different. But then we will be able to make properly designed simulation. So this is a conclusions slide, but I think that I already said maybe more than I had. That I don't know how much I told, but I hope that it was not boring for you to learn what we did within this project. And we really hope that this will lead to something which is effective, because it's really important to have, we can say, an holistic approach and try to tackle the issue of port noise at different levels with different instruments, because it's really a complex task, a complex issue. So thank you very much.
Thanks, Davide, for a really very interesting presentation. I will give some space for questions from the public, if any.
Of course.
I've got one.
Yeah.
When you showed us this second video with noise in the background, and I see also the acoustic map from your system. I have two questions, to be honest. One, was it a particularly range of frequency, or it was the total level you showed us?
The maps, it was the overall, yes.
The overall, okay. And the second question is, which is the technical system you used for this acoustic imaging you showed us?
I mean, the acoustic camera.
Yeah.
The acoustic camera is made from Acoustic Camera, which is, I think, the first company. So the actual name of the company is GFI Tech, which is in Berlin, but the brand which they sell is Acoustic Camera.
Okay.
The model is Star 48 AC Pro. So it's a very good one. It's really expensive, but for example, the camera is a high definition camera, so that allows you to have full HD videos. It has it's huge, so that's why I mean, with smaller ones, sometimes you have a frequency range which starts at 500 hertz. 500 hertz. So it's not really usable in the. If you think about the ship noise, you definitely have lower frequencies.
Yeah.
We had to use a huge one, a huge acoustic camera.
Okay. Any other question, if any, from the others? I think no. So thanks again, Davide, for the very interesting and comparison. So we are not alone on working on noise on parts.
Of course.
Thanks again. So I think it's time for Jaime.
Yeah. Good morning. Good morning, everyone. David, I had to say that it was a fantastic presentation. The last part for me was amazing because, you know, I am not engineer in sound or any other thing. I'm economist, and that kind of things are for me very, very interesting. Thank you very much for your presentation.
Thank you.
Well, I will share my screen if I can. Not this one. Did you see my screen?
Yes, we do.
Yes,
we see from traffic to noise translating port landing data into port noise data.
Okay, that is what I was intending to present. Well, this is where how we want to explain which is the work we have done in this activity, is how to pass from the port traffic planning language to the port noise analysis language. And this is what we learned during the project, thanks to the support of Siriaf and Samuele Schiavoni. And here we go. This is the activity B3 of the project. to prepare a port noise management guideline. Then I will explain what is the Port of Melilla, how we are, what are we doing. Also, then I will go into the characterization of the noise sources, speaking about different things we need to consider to produce this. Also, some words about the geographical definition and limits of the model, and then to the results. I mean, I'm not going to enter into detail, but just 2 or 3 things that were very relevant for us, because this part is for Samuele. Well, the methodology for the preparation of the port noise management guideline is it's something that we need to understand to be able to do our part of the task. And this is what we learned, that we need to characterize the noise sources. As we are going to work in a planning port process, we need to think in the noise sources as a current noise that is already producing in the port, but also the future noise we are going to produce with our planned activity. Also, we need to understand which is the geographical definition and limits of the model to understand what things are to be defined in the port expansion planning to be useful for producing a future port noise map. Then the realization of the noise map, we made thanks to Shiriaf and using the data we gathered in the port, the noise assessment, and then the noise management, which is the thing. Well, the Port of Melilla is a very little port in the north of Africa. Here down you can see the Spanish south coast and the Africa north coast, in which coast is placed the little town of Melilla, also the little town of Ceuta in the Strait of Gibraltar. This is the port in a more close view. We have 3 areas today: the commercial port, which has the industrial activity more connected with bulk, with the solid bulk and liquid bulk, the containers activities, things like that. Then we have a passenger terminal, which has a lot of activity during the summer because of people from Morocco going coming from Europe for spending the holidays in Morocco and the way back. And then we have a marina, which is dedicated, of course, for the leisure shipping. Very close to us is the port of Beni Ansar, which is a Moroccan port. And this red line is the division between the 2 harbors. We share the entrance of the ports, of the 2 ports, and it's a very unusual situation in the world to share the entrance of the port. And then there is the subject of our study. If you can recognize, this is the industrial area. I told to you, this is the passenger area and the marina, and this is the port expansion we are defining now. Well, as we are going to work in the project phase, is the best phase to reduce impact of noise during the work design. For being able to produce that information, we need to define 3 scenarios in which we will gather the information needed. The first scenario is the alternative 0, which is the situation of we do not do anything, and we need to imagine and define which is the activity that will produce in the future in the port we have today. And then we define 2 different solutions in the port expansion, keeping the same structure and moving things from one part to another in one solution and in another. Then we are able to compare the three scenarios. But also we need to because of the real activity of the port, is to define 2 seasons during the year about the port activity, because we have a high season during summer, when we see that activity that I mentioned before, that huge amount of people coming from Europe to Morocco and backwards, and this peak is very relevant, and we define a high season time during the year, which is in between 3 months of the year, and the rest of the season we define it as a standard time. And also we decide to make 3 forecast horizons, 10, 20, and 30 years. Well, in the characterization of noise sources, we need to identify that group of activities that are going to evolve in different ways following that classifications I showed you before, and also that we'll have a different port planning decisions to be taken in the analysis. So we decide to group it in these kinds. As port terminals, as such, we have the passenger terminal, a container terminal, a railroad terminal, a petrochemical terminal, a terminal for bulk, which is hybrid into solid and liquid bulk, and a cruise terminal. We need to define those activities to be able to define the future port noise sources. But we also need to take decisions about the ships that are going to give service to all these activities. So the ships that will give a service to the passengers terminal, also the container terminal, which are of course different ships, and this analysis also lead us to define the specific ship that are going to be used in the different scenarios in the port. Also, the same decisions had to be taken regarding to the port equipment and to the load and unload of the cargo. Also, the equipment and machinery needed for the exploitation itself. So the onshore operations like grouping, moving the traffic connected with the coming in and out to the terminal. And finally, we define some different industrial activities to be moved from the city to the port expansion, which is the production of energy and industrial area for different logistic activities, things like that. Well, this chain of decisions was implemented following taking information from different sources. One of the main sources is the technical project of the port expansion itself, which lead us to a geographical definition of the exact dimensions, height, materials that we are going to use in the port expansion. To have a more detailed view about the activities that are going to be that we are going to see in the port, we use the Mayport methodology, which is defined by the Puertos del Estado, which is our headquarters in Madrid. Also, we use our exploitation data and our experience and how to deal with the needs of the exploitation with the Port of Melilla. and we also use the recommendations for maritime works, recomendaciones de obra marítima in Spanish, that it also is produced by state ports. And these kind of documents are the core of the port planning in Spain. So this is one of the things that is important to understand. We build from this port planning information to lead to the final document I will show you after, which is what we produce for CDF, for them to make the part of the job. Also, in all these steps, we had the support from CDF to understand what was needed from them, and we dedicate the time to understand how to get to that final result that CDF need, building from our experience and these documents. So, what kind of data we analyze? Also, we analyze the port traffic predictions, what we expect to move in the different traffic I showed you before in the future, in different moments of the year. What kind of ships or vessels are we going to use? The number of operations, the intensity of the activity along the time, which is the rate of using of the different quays, and then we can understand which part of the year is going to be under pressure. Also, with the same kind of data we need to produce from the operations onshore. So how big do we need to have the different surfaces for attending the different traffics we expect in the future? Which is the frequency of the using of the different surfaces? What kind of machinery? What kind of machinery for the line of operations? How many trucks are going to enter in the port for giving for putting in and out the merchandise or the passengers coming from the city to get into the port? And also, of course, grouping the activities in the different branch of the different times in along the day, following the national regulations. Well, so we begin from an internal document, which is our analysis of demand for the port expansion of Melilla. We produce a brief specific for the project, and this is what is inside. Of course, we build from the existing data in the port. Then we understand how they move because of different reasons. This is a port planning work as usual. In any port responsible can understand this kind of charts, are not very simple. Also, we have the evolution because of different from different reasons in our environment, that explain why this data is evolving in such that way. Also, we take from that planning document how should the port expansion can be made, or the different uses of the different part of the port. And then we go into the planning work of understand which is the relation of the economic circumstances we expect in the future, the business of the shipping, and the new infrastructure we can offer to the markets, and what results we do expect in terms of future port activity. So regarding to liquid bulk, because these reasons we expose here, which is a port planning work, we expect a future quantity of movements connected with the liquid bulk, also with the ro-ro ships, passengers, the different traffics we mentioned before. And then we produce a forecast. Different traffics. This is a regular line, ro-ro traffic, liquid bulk traffic. Then you can see how should this evolve the demand for different reasons in the case of the project. But we have another graphic of about how should it evolve without the project. This is only to give you a view. For instance, here, sorry, listen here, we can see the tones we expect to move with the project and the tones we expect to move without the project. So this is the idea. No? Okay. Well, if we had to attend these future traffics, we need to understand which is how we are going to make that. This part is not very commonly introduced in the port planning because these are problems that we are going to solve in the future as the traffics really become real. But we need to make this in this moment because we need to produce that info for the project. So we produce the decision we should take about what kind of vessel will attend the different traffic. So for the ro-ro vessel, now we are using this kind of vessel with this volume of cargo, the length, beam, draft, the number of UTs they need to work, and the scale time. But also, this is what we have today. But in the future, looking at the traffic they need to manage, the future vessel will going to be different, much bigger, longer, wider, deeper, and moving a bigger number of UTs of machinery for the load and unload of the cargo. But the scale time is going to be shorter. Of course, we have one line, and we need to, if we are going to move a lot of a bigger number of cargo, we need to be faster in the loading and unloading of cargo. This kind of analysis also in the different traffics. We have different charts for passengers, bulk ship, liquid or solid bulk for all the traffics. Also, for the activities we define to be moved from the port, from the city to the port, of course, we have a surface occupation forecast in the different years, and we decide what to expect in the intensity and the average percentage of use. So we also expect to need more space in the future than we today define. Then how to translate this into the specific hours of working. For make that calculation, we take the info from the recommendations of maritime works, in which we can see that kind of information, which is the technical data which is relevant to attend the activity. It depends on the number of birds we have for attending the activity, the average containers that we can move in with a transoceanic vessels or a feeder vessel. For instance, the speed that we can see in the operations, and then we use an algorithm like that or a formula like that, using that information, technical information from the ships. And this is the solution. Then this is how we decide the number of cranes we are going to need to operate with the physical terminal we have defined in the port planning to attend the demand we have defined in our port planning document, and having an average information about the technical production that we can expect from this machinery. This is the recommendation we have for that, and this is the number of cranes we are going to use to give as an input to the model of noise to understand which is going to work in the terminal in the future. And we made this work for the different horizons, for the different seasons, for the different traffics, and that is how we translate from document planning for port planning documents and approaching to the and approaching to the information that the here we are, and approaching to the information that we need to give for our noise modeling. And using that is what we finally achieved, which is the table of communication in between the port planning to that. Let's go make a shorter view, and we are very near to the end. Well, what we see here is the season peak month. So it is in the summertime. It's in the we define here with the project made. We are in the horizontal time year 30, and with the traffics defined in those moments, we need to, for the terminal hub, so there is a table like that for the ship terminal, for the ro-ro terminal, for the container terminal, the rest of the port activities we define. We see the ship call is a transoceanic ship, the feeder ship that is going to move the containers from our port to other ports that receive, the main cranes, number 1, number 2, the crane number 3. So these are the 3 cranes that are foreseen to be used. Still, we have the crane 4 and 5, which they are going to work for the feeders, transteiner, reach takers, diesel forklift, the trucks that move the containers from the dock, from the side of the ship. These are the reefers containers, the containers that need to be refrigerated, has an engine inside, and the trucks that are going to move to enter and put away the containers from the terminal. And this is what we define. These are the 3 gaps, or the 3 times in the day, which are they have been regulated in the Spanish normative: the day, the night, and the evening. And during 1 month, we expect to operate the day 1, 4, 7, these hours in this moment with this machine, and with the other machines that are for the ship entering three days in the month, and the feeder is entering one feeder each day along the month. But one day they are going to expand the operation the whole day. So it is this day we will have 2 ships, and these are the hours of the cranes of the work of the cranes each day of the month. And this is the same job with the rest of the machineries. So this is the final objective of the work. This is the language that the port noise analysis need to have to start their analysis. So I don't want to extend more my presentation because it is becoming late, and just only say that this is the final production. And I only want to remark one thing is what interesting is that for us, I just want to mention that this building you can see here is the passenger terminal we have in the port today, and then you can see the protection that it offers to the city of the sound that comes from the hub terminal. And if we have that information before we made that passengers terminal, we can have selected another way to put it in our terminal and to make more efficient the protection that it gives to the city. Also, we have here this line, you cannot see it. It's a dike wall that protects the port from the waves, and it is also makes a protection for the noise that it's producing. Then you can see the red image that it is stopped here by the dike wall. This kind of information is very relevant for us. Also, the different effects that how we dispose the rows of containers in the port terminal is very relevant for us, because it's not very relevant for us to put them in this sense parallel to the line or perpendicular to the line. And this kind of information is very, very useful for the port planning and for the port exploitation, and it costs almost nothing. For us, it has been a very exciting process to participate in the project. We have learned a lot of things about our own port, and from my side, this is the end of the presentation. Thank you very much.
Thanks you, Jaime. Really comprehensive and clear presentations for you. Time for questions. Jaime. Good. So I think we can go on with Samuele, which is the last speaker, and it's a natural prosecution of the work made by Jaime. And I see him connected, so please, Samuele, you can go on. And thanks again, Jaime, for your nice presentation.
Good morning to everybody. Now I'm sharing my presentation. For just a moment, please. Can you see it?
We can see your screen now in the PowerPoint.
Okay.
Yes, yes.
Now it's okay.
Well, okay, as you say, Giorgio, my presentation is a prosecution of the one of Jaime. Probably I will repeat some part that has already been presented by Jaime, but I will try to treat this part from a more acoustical point of view. Of course, concerning the noise mapping of the expansion part of Melilla, we have a deep collaboration with the Autorità Portuaria di Melilla, because we need to interact and to coordinate with them in order also to move the project and the expansion project in a way that is more compliant to the standards of the of Melilla Port Authority, and also to relocate the target of the layout of the future port. Well, let's start with the core part of the presentation. The first part, I will propose a brief introduction about the project, and then I will try to define which are the target of the noise mapping activity in Melilla within the Anchor project. Then I will describe briefly the Melilla port areas in the current and the future layout. Then I will propose how the scenario assessment has been made within this project and is currently being made, because we decided with the expansion of the project to relocate some part, relocate some activities, and so the project is currently in definition, even if the noise mapping project is practically closed. Then I will report how a noise emission data has been collected and treated, and because I was a newbie in the beginning of this project on the noise mapping of port areas, and I have to thank Professor Davide Borelli to give me a lot of hints, a lot of suggestions about how to characterize the most relevant noise sources that I may encounter on a project of this kind. Then I will thanks to this collection, I was able to define a database of port noise sources, and this one is probably one of the most important milestones of the project, even if it wasn't included in the target of the Anchor Live. I was able to build this database and also to share with a lot of researchers that are working in this field. Also to have, first, to have a feedback. Second, to share all the knowledge that we built during this project. Then I will briefly report some outcome of the noise mapping activities and how this outcome has been used to define a port noise assessment method. Then a brief discussion about which will be the further developments of the project. Well, my presentation, as I repeated before, my presentation is about one of the most important outcome of action B.3 of Anchor project. And this part is named Noise Mapping of Melilla Port Expansion. The aim of this action is to update the NAMPORT's Good Practice Guide, taking into account the innovation introduced by the European Directive. This Good Practice Guide was one of the first attempts to furnish a good practice guide about how to manage the noise simulation of ports. Because we have there are a lot of projects about how to model an agglomerate, about to model a road, maybe less about rail, a lot about airport, but ports are kind of sources that are currently not so deeply treated from an acoustical point of view. And this probably is due to its extremely complex situation, because how Borelli reports before, the ports is a very in a port there are a very huge group of noise sources that are very big, and this is not a secondary element. And because all the standard that we currently have that allows us to characterize the noise emission of a noise source are not so tailored and are not so very usable, very easily to be used for big sources, such as a ship. And so this is probably one of the most the hardest task that we encounter in this project. Then a second aim of my presentation is to report how a common port noise impact assessment method has been designed and how this has been tested in the case study of the Melilla expansion project. Well, first of all, we have to talk a little bit about what are the target of the noise mapping activity of Melilla. We decided to consider a lot of scenarios. First of all, we decided to take into account the yes or no port expansion. So we also decided to model the port of Melilla in the next year, also in the condition of no realization of the expansion project. Then we consider separately the standard and peak season, because there are some activities that are which emission are very, very different from the season. Then we take into account the evolution of the port in all the scenario that we I discussed before, after 10, 20, and 30 years. So also we was able to define which will be the progress of the port. Then we decided to assess separately each part of the port in order to better understand where we have to foreseen anti-noise measure. And so our action will be more efficient to tackle port noise impacts. Sorry. Well, first of all, we may see, as I reported in the last presentation, we may see that the difference without and with port expansion related to the port areas are relevant. For instance, with the port expansion layout, a hub terminal will be realized, and also a cruise terminal will be realized. This is because a new activity, if the port expansion of Melilla will be realized, new activities will be held in the port. So we are forced to consider in the scenario with the port expansion this new part. Moreover, the new port layout foresee to include inside the port area two activities that are currently very noisy. The thermal energy plant that is currently placed outside the port area, even if it's quite close to the port area, and the waste incineration plant that is currently placed a little bit far from the Melilla port area, but in the new port, the Melilla Port Authority decided to move this incineration plant inside the port area together with the municipality of Melilla. This is the layout of the port expansion. We may see all the new area. And in particular, we see the area interested by the new waste incineration plant. It will be placed in this part. And also the part interested by the thermal power plant. For instance, currently the thermal power plant is placed here. if I'm not wrong. And I see it when I visit Melilla to make some measurement on site, and I will discuss it about it later during my presentation. And I have to say that especially in the night time, the impact of this thermal power plant is relevant, because it's clearly the noise emitted by this power plant is clearly to be heard. Well, for each area has been considered all the equipment, facilities, and activities having a relevant noise emission, the typology of the moored ship, and also the traffic of normal and heavy vehicles that interested in each area. So for each of them, their monthly average working hours have been reported, thanks to the cooperation of Jaime and of the Melilla Port Authority, in a way that Jaime clearly reported during his last presentation. So this monthly average has been assessed in day, evening, and night condition during the normal and peak condition. And for peak, we are talking about the 4 summer months. After 10, 20, 30 years from the present, and also considering the possibility of managing the future development of port without realizing a port expansion. This is an example on the peak month without and with the port expansion of the container terminal. And we may see that with the expansion, the usage of the number of the ship for month is bigger. It's 17 against the 15 without the port expansion. Okay, and this is only the 10-year scenario. You have to consider that we have also the 20 and the 30-year scenario. And so these are not all the noise sources that has been considered inside the container terminal. Is a very, very brief extract about it. And you may see, for example, in this case, the mobile crane and the Panamax crane, the gantry crane. So these are the, I repeat, for no expansion project, the usage of all the different sources that have been considered, that has been considered in the project. And we also take into account the heavyweight traffic also. And we may see that with if we consider the standard or the peak month, in the peak month, all the values are a little bit bigger. If we consider the yes expansion project, the value are even bigger than the one that I reported for the no expansion scenario. So we may, I think that I try to report how much a project like this one can be complex to be assessed. But if you have a better idea about the complexity of this project, we may see the number of sources that has been considered for each scenario. This number does not consider the RoRo, the cruise terminal, and the parking as a road, because they are not so, they weren't able, all the concerning the RoRo terminal, the cruise terminal, the parking and road excluded, roads, the data about this element are excluded from this table, because when I when I prepared this table, this data weren't available. Recently, Jaime sent me all the data about these sources, so probably I will be able in a few to update this table. However, we may see that, for instance, with the yes expansion project, in the peak season after from 30 years from now, I have to consider about more than 240 noise sources. So it's a very, very complex situation, a very complex project to be modeled. Even in the in the easiest scenario, I've modeled more than 80 noise sources. So you may see that, you may understand that the situation is very complex. This is a brief table in which are contained all the how I obtained the noise emission data of all the sources considered in the project. Concerning the cement carrier, the raw packs, the tanker, I decided to take this data from noise measurement realized in situ. And I used the silent view procedure, and I report this procedure in the next slide. There is also a cement plant, and about it I perform some noise measurement. While concerning the cruise ships and the RoRo ship, I take data from ISPRA database, efforts, and Green Cruise Port project. For container ship, I decided to use the simple John-Witt equation. Is reported on one of these papers, and probably is not. The source is quite a little bit old, but it's quite affordable. Then for the forklift, for forklift, I take the Green Cruise project, Gantic cranes and trastrainer. I take into account the deliverable or effort project, but I have made a little elaboration on this data because the Gantic cranes and trastrainer that I used in Melilla works in a little different way from the one that have been considered in this project. For parkings, I use the Bavarian parking lot model because it's the most affordable method to assess parkings. For each staker refers, I take into account the report project, and also in this case I made a little elaboration. Roads, I use the Knossos model. And while for the thermal power plant, there was incineration plant, I take into account the data from Checor and Municipality of Melilla. Checor is a private company that performed a noise simulation study of these two elements during the simulation of the agglomeration of Melilla for the simulation compliant to the END directive. Concerning tractors, I consider simply the heavyweight traffic of the Knossos model, and finally for the wheel cranes, I take into account the Samplan database. So concerning the RoPax ships, a cement carrier, the oil tanker, cement plant, and also the HVAC units placed in the roofs of the Station Marittima di Melilla, I perform some measurement performed directly in Melilla. Well, this is the first RoPax ships that have been characterized during mission in Melilla that have been held in the February of 2021. This is the first one, that is the second one. They're very, very big ships. Then this one are the cement carrier and the oil tanker. I wasn't able to characterize other kind of ships because during my visit in Melilla, these one are the only ships that were present in the port. No container ship arrived in the port during the period. And this is how the characterization of the noise emission of the ships has been performed. I use the silent view procedure, so I perform a group of noise measurement on point placed at 25 meters each from the ships, and at a distance about 10 meters one from the next one, at an height of 1.2 meters from the ground. While for the HVAC unit of the Estación Marítima de Valilla, I went on the roof of the Estación Marítima of the building, sorry, and we power on separately each unit placed on the building, and I try to characterize its emission, taking into account the indication of the ISO procedure, but in some parts it was impossible to follow it literally. Well, this is an example of the database that has been realized. This one is one of the outcome of the project, and we may see the export in Excel, and we see the emission in octave or 1/3 octave of different kind of noise sources. You may see RORO is for, there is a legend, RORO is for RORO ship, for instance. It has been defined from this report in this way, as a single point sources for the complex activities, and that these single point sources represent the whole sources. And in this case, the one that I take into account, sorry, this one is a ROPAX, sorry, not a RORO, is given directly the LV point A, not the repartition of not the 1/3 octave level. But you may see that there are about more than 70 noise, more than 70 noise sources that can be found on a port, and so that this, I repeat, this is probably the most interesting outcome of the project, because personally I use this database also on a private project that I'm currently following on another activity. Well, let's go back to the presentation, and let's the report discuss briefly about the noise mapping method. We decided to perform a grid noise map and facade noise map, and the simulation were performed in components.
I missed somewhere. Is it a problem with me?
No, I cannot hear him as well. I think he got disconnected.
Yeah. I'm writing him. Let's see what happens. Try to call him. Let's wait a moment. He seems he lost the line. He was more or less in the line.
Sorry, there is an inconvenience during my presentation. Probably also the computer starts to sleep after for my presentation. However, we'll start again sharing the. Can you hear me now?
Yes, yes, you were on noise mapping at slide 7, not slide 7, point 7.
Okay, I will. I think you are here.
Yeah, please.
Okay. So I was talking about the difference between green noise map and facade noise map. Briefly, I don't know when the interruption happened, but I just want to say that green noise map allows us to have an idea about which is the propagation of the noise in an area. Facade noise map allows us to design anti-noise measure and to define what are the impact of a source on a receiver. Well, we decided to the area of the port that had been considered separately has been already reported, and this one is one of the maps that have been already described by Jaime. This map represent the emission of the container terminal in the peak season after 10 years, without the expansion of the realization of expansion project. We may see which are where the noise tends to propagate better due to the emission of the container terminal. But I remember that this area is related at an height of 4 meters from the ground. So if I place a noise barrier and there is a noise barrier having an height of 4 meters, for example, I may say the effect of the noise barrier with this noise map. But if I perform a simulation, a noise map, if I perform a simulation of a noise map at an height of 8 meters from the ground, practically the impact, the effect of this noise barrier isn't more, it cannot be assessed. Is one of the most important limits of the noise maps, because they are related to a ground, they are related to an height from the ground, while the facade noise map, on the contrary, are able to understand the difference between the effect of anti-noise measure. And also they can also show if an anti-noise measure isn't so effective as that we thought, for example. But we can see that with expansion project, we can see that immediately you can see that the area occupied by the container terminal is bigger. Sorry, is bigger. And also the impacts are bigger. And the impacts, even if they are not so relevant from an impact point of view, tends to be bigger in the north part of the port. Okay. So we can see if we assess the difference in terms of emission about the yes expansion project and no expansion project, we may see that with the expansion project, we have higher noise emission in the north part. Okay. Then there are a little, in some part, there are a little bit bigger impact during due to the some particularly displacement of the noise source in the port. But if we see the absolute value is lower than 40 decibels. So these different in this area are not so relevant. Okay, let's go a little bit faster in this part on the port noise assessment method. We define a new procedure that allows us to to understand which noise source needs to be more urgently treated, and the procedure is based on defined group of unknown sources, considering the existing noise limits, and to perform this we need to cooperate with the Melilla Port Authority and to the municipality of Melilla, and then to finally we have to perform a facade noise simulation, and that allows us to individuate, to locate and individuate the noise critical areas. So the so-called hotspots, the area where the noise limits are overtaken. How to identificate a critical area is a procedure that have been tested by a lot of projects managed by CIRIAF, in the past, but the procedure is very simple. So inside a critical area, the distance between a critical building and the nearest to it is lower than 100 meters. We define a cost-benefit index thanks to the one that has been derived from the one developed in the data project. So we decided to perform a ratio between the cost of the measure and the difference in terms of index of priority before and after the measure. And all these difference has been multiplied by a correction factor that takes into account that not all the measure allows us to obtain to reduce the index of priority in the same way. For instance, if I decide to solve the overtake of a noise limit, placing simply furnishing a building of anti-noise windows, I have into account that during the summer season, if I open the window, the effect of anti-noise window practically is equal to 0. So we decide also to take into account this element. And then this equation reports how the index of priority is calculated, and I don't want to report each part of this equation, but I just want to say that the index of priority is practically assessed multiplying the population exposed to noise to the noise limit overtakes, the noise limit overtaking. And sometimes we apply a correction factor because we decide to consider schools or hospital different from normal houses. In particular, we decide to multiply, for instance, the people that are inside school of a correction factor of about 3, as reported practically in the Italian legislation. So this is an example of the procedure performed for in Melilla. I have to say that this procedure is not cannot be considered, this outcome cannot be considered final, because we have to work with Melilla to better define the number of inhabitants for each building in Melilla, because we have a data, but this data seems to be too low, and probably there is a lack of data. However, the procedure for the expansion scenario allows us to identify 4 different critical areas. And for these critical areas, we define an index of priority, and we also report which of the noise sources of the port areas is responsible for this index of priority. And we say that practically the most relevant noise sources is made by the for the ROPAX terminal. So it is night, but is made by the ROPAX. We may see that the ROPAX is the most responsible for the index of priority found in the project for the expansion scenario 30 years from now. With the expansion scenario, we obtain a completely different outcome. We may see that we identify only 2 different port critical areas placed in these 2 parts, but we can see that the responsible of this noise limit overtaking is due to the ROPAX terminal. We have to work a little bit of improving this outcome, because I still not assessed the cruise ship on this outcome, but I estimate that the impact of the cruise ship will be not so relevant. And I repeat, I have to better calculate the number of inhabitants of each building. So for developments, we have to take into account the figure of merits in the Melilla. So the result has been reported by the Livorno Port Authority will be used also in Melilla to assess the effect of this instrument also in this in this work. Well, that's all for the moment. I will continue. I am currently working to continually improving this the noise mapping project, because I repeat, there is some little lack of data, but I think that in a month everything will be solved, and so I am open now to a discussion of further questions.
Thanks, Samuele. So this circle is closed. Space for question, if any. So as before, simply there is no question from the audience. So I think we have arrived at the end of the webinars. Thanks again, Samuele, for the detailed presentation. And I think we can consider the meeting of today closed with a few minutes before the foreseen end. And Giuseppe, I give to everybody appointment for the next webinar. You have told before at the beginning of the morning, but I don't remember now. I think the next one is the 23rd of November. We can hear you.
Yeah, correct. The 23rd of November.
Okay. And so again, thank you everybody, and see you very, very soon, in more or less a week from now.
Thank you very much.
Thanks again, Davide, for being with us all the time.
You're welcome. Yeah.
And for the nice presentation.
For the invitation. Thank you very much.
So,
Thank you.
Thank you, and bye, everybody.
Thank you. Bye.
Thank you.
Bye.
Bye. See you.